I have already done a part of this. So general aptitude PYQ discussion is going to be part 1 and 2. I have done part 1, and what we are going to do is part 2. Part 1 is special in the sense that is try to solve most of the questions using general sense, not common sense, sort of a special general sense, right? Eagle sense, spider sense, and all that, right? So, in that sense, part 1 is specifically interesting and it's sort of very special, and we'll complete it and we'll complement that with part 2. We're looking at gate biomedical aptitude, but aptitude, most of the things like intersect, right? So you get a very good idea on list of questions, the distribution, weightage of questions, what they typically are, and also lots and tips of how you can go about answering them very, very easily. That is the objective of this. Let's get started with part 2. Discussed many questions where I left off. Suppose I remember discussing the speed, distance, time problem. Oh, I have some analytical aptitude, some questions based on logic. So there are seating arrangement questions in a circular table and then seated in a row and corners of a triangle. So again, let me highlight at this point. Notice an MCQ. This you have to pick one out of 4 options. True or false, which it's not there in gate syllabus. Notice this is relatively easier. One of the 2 options is correct, right? MSQ. There are 4 options. Any non-zero combination is correct. What is the probability of getting the right answer? This is 1 out of 60. This is what makes MSQs hard. You have to check all the correct options and only the correct options of the incorrect option, right? A, B, C, D, A, B, B, C, C, D, D, A, D, B, right? A, B, C, B, C, D, A, so there are 16 combinations out of which 1 is correct. Notice this is orders of magnitude harder. Often in analytical aptitude, number of combinations kind of float combinatorially. Typically, PQ or ST seated this way. It can be here Q. You do permutation, combination, factorial, right? Exponential. So it just explodes. And in fact, often you are talking about 1 out of 50 cases, 1 out of 100 cases, and all that, right? So this is the hardest. Be careful about this. But having said that, you can be smart about how you answer this, right? And a good example, pop culture example that I gave is this movie called Imitation. What did you do during the World War? I work for a factory or something like that. What did you do during the World War? Are you listening, right? Some sort of logical conversation will be going on in the trailer or teaser. So this notice they'll be trying to break some codes initially, which most people will think impossible. One is they will be using computers. And even using computers, they will not be machines. They will not be able to actually crack the code. Then finally, there will be this, change point, inflection point in the movie where they realize if you actually constrain, there are specific strings, text in the messages that the Germans sent repeated. Hail Hitler, for example, the time, for example, some of those details will be repeated. If you use that and constrain your decoding, the problem gets much easier. Okay, so the takeaway point is you can convert some of this hard combinatorially exploding, problems. You can simplify them. Use this tactics called what I refer to as constrained elimination. Constrained elimination. Make sure where you are searching the answer for is a sensible, meaningful, feasible set, region, location. Somewhat of a technical term, but I think this is somewhat informal, casual. Constraint elimination, I think, is kind of self-explanatory. So we'll stick with this. I'll show you a couple of examples on what I mean by this. What I mean by, hey, there are like 50 combinations, things like that. I'll show 1 or 2 quick examples. So the first problem that I have here is PQ or ST. We are seated around a circular table. S is seated opposite to W. U is seated at the second place right of or T is seated to the third place to the left of R is neighbor of yes. I'm going to solve this as if I am uninitiated. Let me quickly see. This is seated opposite to W. This is a circular table. Let's also get some guides. This is left hand side. This is right hand side. This is left hand side. You were seated at the second place to the right. How many of them are here? 1, 2, 3, 4, 8 people. So 1, 2, 3, 4. Then 1, 2, 3, 4. All these spots need to be occupied. And I suppose there aren't any gaps. Seated without gaps around a circular table. Let's presume that and move on. You were seated at the second place to the right of R. Notice at this stage, there is this question. You were seated to the second place to the right of R, right? So where is R? R can be here. R cannot be here because R can possibly be here. If R is here, notice the second place is already occupied. You cannot take a seat here, right? R can be there. R can be here. Second place is available. Or cannot be here. Or can be here. We have 4 possibilities. D, right? All of a sudden, just filled 3 out of the 8. And V is the neighbor of yes. So notice already the moment I put in R, there are like 4 possibilities and each of them will like branch, right? This loci sort of this branching paradox, combinatorial paradox we do have. So the first question I would ask is, I am given 4 bits of information. Which of the 4 bits should I use here? Or in this case, is it immaterial? What do you think? There are 4 bits of information given, or all 4 one and the same, or should we specifically start with, a particular piece of information? This is like there are 5 bowlers in the team. Should we start the match with Bumrah or should we start the match with some other part-time bowler? Is there a difference in this case? P is a neighbor of S. V and S are kind of together. Eliminates one position of R. In fact, I am asking even before I put S and W there, where should we start? Which of the, let's not really start here. I just went by the order in which information was given. Is this how you should proceed, or is there a different way you should proceed? Information need not be given in a convenient order. In this case, in fact, notice one suggestion is do 1, 4, 3. Do it in that order. Fine. I'm just writing down the suggestion here. Would work on, but quickly when I read this, my strategy is I would either fix the location of yes, because where W is with respect to S, that is given. Where V is with respect to S, that is given. 2 pieces of information relating to S is given. Or I would start with R. 2 pieces of information relating to R is given. U is seated at the second place to the right of R. T is seated at the third place to the left of R. So once R can be without laws of generality, you can place them anywhere in the circle. With respect to R, you can place the others, right? Here also with respect to S, you can place the others. So let's start with yes. Yes or R, in this case only 2 pieces are given. So let's start with yes. 1, 2, 3, 4. 1, 2, 3, 4. If this is yes, arbitrarily without laws of generality, I'm picking that. W is here. Next piece, you don't know where U is, you don't know where T, R and all this. With respect to S, V is a neighbor. Now, the timeline branches. Because which side neighbor is not mentioned. So that needs to be accounted for. The multiverse needs to be accounted for. And we'll prune that particular universe or timeline by the time we add more constraints on that. So right now, where S is, where V is with respect to S, whether on the left side, right side, it's not mentioned. Let's also give the signs. Is the right of S, is the left of S, right of S, left of S is not known. So I'm going to consider both the cases. The right case should actually satisfy all the 4 criteria. So here we have V, here we have T. Then U is seated at the second place to the right of R. E is seated to the third place to the left of R. Which one should we use? I think at this stage you can use anything else. Where should we put U and R in this case? R is here. R can be here. R can be here. 2 places to the right and 2 places to the left. That makes or here. I have two places to the right open. I have two places, three places to the left open. As in going clockwise, I have a spot open. Going anti-clockwise, I have a spot open. If R is here, not possible. If R is here, the second right place is occupied. R cannot be here, of course. If R is here, the third left is not occupied. If R is here, the second right is not. That is the only space for R. And given that, we can also put where U is, U need to be here. The spot, U can be there. And then T is stated at the third place to the left of R. This is 1, 2, 3. T needs to be here in this case. That leaves only spots for who? T and P and Q. There can be PQ here. I'm writing possibilities. P or Q. P or Q. No conditions, constraints are given on them. So it could be either P or Q. It's not P by Q. P or Q. So P is a neighbor of R. Q is the neighbor of R. P is not seated opposite to Q. This is true in both of the cases. R is a left neighbor of yes. No, this is incorrect. In all the possibilities here, option C is correct. A and B can be correct. In fact, P, so the given thing kind of satisfies all the information, right? So this holds good. P and Q cannot be opposite. We can conclude it. It satisfies all the given information. They cannot be opposite. We can conclude at this point. In fact, we don't have to really worry about case. Yeah, I am recording this, likely available in the recorded video. If it is not decisive here, in that case, we'll also have to find that universe where the Wanda's children are alive and we have to make Wanda happy, right? By getting them together. So fortunately here that scenario doesn't occur. At this stage, we can answer. So this is, notice, possibilities of R, possibilities of the order in which you use the information, things are hard. So this analytical aptitude logic is tiring. Do towards the end of exam, and be careful which of the given pieces of information that you use. That makes a lot of difference. This problem is not very illustrative on that, but I'll show a problem on that. Always do constrained elimination. Can do constrained elimination. In fact, trying to look for a place for R can only be there. I'm kind of constraining the possibilities. I showed 4 possibilities, right? I kind of ruled out and only kind of sort of constrained it, right? This showed up midway during the problem, but the earlier you do that, the easier it's going to be. I'll show you a slightly better example. And what is this exams in some business going on? Some of you have exams. That is fine. I will try to make this. I'm recording this. Some version of it should be available. Let's get to the next question. 4 persons PQRS or to be seated in a row or should not be seated in the second position from the left end of the row. This is kind of fairly easy, I suppose. There are only 4 people. They are all sitting in a row. So this is 1, 2, 3, 4, right? And R should not be seated in the second position from the left end of the row. Which is left, which is right? Let's put this is left, right. R shouldn't be from the second position. R cannot be here. So in that case, possibilities open up for R. R can be here, R can be here, R can be here. R cannot be this position. From the left, second from the left. So PQR can occupy the other side. So it's either this world or this world or this world. One of the 3 worlds. How come the screen is not shared? Yeah, we can pick, let's pick left and right like this. There are 4 spots. Or cannot be in this position, right? Or cannot be in this position. So R can be here or here or here. 3 possible worlds, top, middle and bottom. So either it's world 1 or world 2 or world 3. Here it can be P, Q, yes. Possibilities here, 2 possibilities here, 1 possibility here. This and this and this, right? That makes a total of 6 possibilities in this world. Any 3 here, any 2 here, any 1 here. That makes a total of 6 possibilities in this world. Any 3 here, any 2 here, rest 1 here. That makes 6 possibilities here. And because it's an R, these things get added. 6 plus 6 plus 6. That is 8K. This is fairly easy. A screen issue is resolved, I suppose. The corners and midpoints of the sides of a triangle are named using the distinct letters P, Q, or S, T, U, but not necessarily in the same order. Consider the following statements. Line joining P and R is parallel to the line joining Q and S. Triangle and midpoints. So notice P, R, Q, S. P, R, Q, S. Can technically rotate the triangle, but at least that is the generality. You can flip the triangle and have instead of Q here and can have it here, right? So notice at least there are two possibilities. But then you can also have P, R, sorry, this is Q, S. Those two are parallel. P, R. And then we can have Q, S, and then P, R, right? Already four possibilities. Then we have this T, U, and all that we have to fill up, right? But let's start small. Which of the four or three pieces of information should we start first with? Let's not start in the order that is given. Line joining PR is parallel to line joining QS. Let's not do that. What is given may not be the favorable thing, right? First name alphabet, name starts with A, doesn't mean he should go on bold first. Name starts with B, name is Boomrah, he can go bold first, right? Which of the three options should we start with? That's very, very important because this is like lots and lots of possibilities. At the end of the examination, this is one question where you will be wasting time even at towards the end of the examination, where you're done with all the easy questions. Because one or two other moderate questions you could do instead of wasting time on this hard question if not approached correctly. Line joining P and S is parallel. PR is parallel to Q, yes. Where is P? Where is R? Right? So no, P is placed on the side opposite to the corner T. Where is P? Where is T? S and U cannot be placed on the same side. Look, relative information between S and U, relative information between P and A. No. This is not relative information. There is one piece of absolute information. T is a corner. I'm going to start with that because a certainty is mentioned. It's not a relative thing. One specific thing, the T is in a corner. You know that. That is very powerful to start. Let's put the T over there. Let's also make this somewhat color consistent. So the T corner, again, without laws of generality, you can rotate the triangle. Rotation invariant and scale invariant, flip invariant. So let's put this T over there. Sir, why not this corner? Why not this corner? T is a corner. With respect to that, we can mention other things. If you flip the triangle, you will easily get it. We use the word without loss of generality. I had a friend, if you ask him a question, in fact, if he takes up a phone call, he wouldn't say hello. He'll be saying without loss of generality, WLOG, right? So, without loss of generality, he is a mathematician, of course. So we have this triangle. Next, what do we use? Next, PR is parallel to Q. S and Q cannot be placed on the same side. What do we use next? S and U. Now, none of it is with respect to T. Again, I haven't really used the second. P is placed opposite to the side corner of T. That happens to be here. Great. Now the multiverse timeline branches. I got T at the top. T at the top. P can be a corner here or P can be a midpoint here. Why not P this corner? Same thing. If you flip this case, you get that, right? So I'm kind of adding flip invariancy. This is like phones flipping phone, right? You're kind of aware of it. So yeah. Now given the, you can, the R's location and all that is fairly easy, right? Q and S has to be this. Given this part, given the location of P, this is fairly easy. All right. It's either QS. Again, there is a sort of timeline branching, but let's see if we can rule out any of these cases. QS, R is parallel. This is the case. I had to put S and U cannot be on the same side. R cannot be here. S and U cannot be on the same side. That makes R here. And PQ, R needs to be here. So now I have ended up with two possibilities. P cannot be placed at a corner. No, P can be placed at a corner, at least in one of the worlds. S cannot be placed at a corner. In both the worlds that I have, S is not in a corner. Let's see, U cannot be placed at a midpoint. No, U can be placed at a midpoint in one of the worlds, or cannot be placed at the corner. No, or actually is at the corner. The second is the answer has to be yes, cannot be placed. Yes, can be. Yeah, yes. Which of the options are true, right? Correct. Yeah, yes. Yes has to be in the midpoint in any of the worlds, right? So this, at least I have ruled out other possibilities. Some of the worlds, other things are not, or incorrect. There is a world where can be at a corner. There is a world where you can be at the midpoint. There is a world where or can be at a corner. I haven't explored all the worlds, but I have found counter examples, so I ruled them out. B is the answer. Yeah, this is a good illustration of constraint illustration. Notice I first did one, then I did, then at this, starting, good start is half done. It boils down to this. Then I suppose these two you could do it in a slightly different order. It doesn't matter. But how you start, pull out possibilities is a very nice question. Probably I'm going to get a call from that friend. I should say instead of hello vlog, vlog. So vlogging is also a sort of vlogging, I suppose, right? Video blogging. This is like without loss of generality. So let's go here. Yeah, imitation game story is already over here. Regularization. There are many easy questions. Analytical aptitude. You call it whatever. It's fairly easy. You have a matrix Mij. Ij is 1, 2, 3, 4. Diagonal elements are all 0. Mij is minus Mij. Talking about 4 by 4 skew symmetric matrix. Symmetric matrix. The diagonals are all 0. Let's take that matrix. Diagonals are 0. Specify what these 6 elements are. You know what these 6 elements are. It's just, they are negative of these elements. So you need to minimum number. You need to specify 6 of them. It's fairly easy. Let's not spend more time on this. Simple thing. So what, this is termed as a skew symmetric matrix of order 4 or size 4. The minimum number of elements required to. If we are trying to test your math terminology, they could have framed it that way. But, they are they have framed it fairly explicitly. So bottom line, no basic definitions of matrices and all that. All this counting, you could do that fairly easily in the examination. What is the smallest number with distinct digits whose digits add up to 45? Distinct digits. I was talking about elimination today. Distinct. Not distinct. Rule out. Rule out. Not distinct. 3, 4, 5, 7, 8, 6, and 1, 2, 3, 4, 5, 6, 7, 8, 9. Sum of this is going to be sum of this. They are all distinct. Smallest here is this. I didn't even count the sum. Both the sums are 1. Summation of B is same as summation of C. Digits of B is same as summation of digits of C. C is a smaller one, I suppose, smaller number. Decoding, encoding problem. Kind of imitation game problem that we get here is if dot circle is P minus Q, right? This is a kind of decoding, encoding that, Enigma mission was kind of doing with characters. Here they are doing it with operators. P plus P circle plus this P into Q. Fine. This is fairly simple. Just write it down. You should get the answer. This is 9 minus 6 into 7 minus 7 into 6 minus 5 happens to be equal to 9 minus 42 minus 7 into 1. This is, how much is this? So the arithmetic part of the brain and teaching explanation part of the brain are sort of very different. We have access to get calculator nevertheless. How much is this? 40 minus 40. Otherwise, it's embracing. I write it as minus 30. Can do a calculation, mental calculation. I get minus 33 or something that, it's embracing. So this is minus 40. Let R be a root of the equation. Then the value of the expression. Whenever they are given you something big, the bigger the thing is, string is, the simpler it's going to get. A rule of thumb. It's a large summation. There is something called telescoping cancellation. Okay, some things are going to get cancelled. How can things get cancelled? If something is 0, it will disappear. Right? They are given you what is 0. So that term is all over here. Okay, so find the zeros here. That's what they are doing. So I am going to do this. First, multiply this and this. In fact, let's do colors. Let's do this and then we'll do this and this. Most of it will be 0 and cancel. So in general, the more bigger, This is bigger. This is this green Hulk. Bigger it is, the nicer person he is. This is a fairly easily dealable character. So if you are looking at a really big expression, you should kind of feel happy because there is a possibility there is something very simple hidden there. So look for things that would disappear. This is r square plus 5r plus 6 into r square plus 9r plus 20. And that is r square plus 2r plus 6 is 0. What is left is 3r. And what you have here is 7r plus. So r square plus 2r plus 6 is 0. That disappears. What is left is 6r plus 14. You can imagine bubble burst, right? This is like just a reflection in a big bubble. And you burst the bubble, there is like a small toy, a fairly benign toy inside that. So this 3 into 7, I am pulling that out to r square plus 2r. This is not disappearing. This is not 0. But if you add plus or add and subtract 6, you got the 0, right? So this is 3 into 7 into minus 6. How much is this? 3 into 7, 21. 21 into 6, 120, 126, minus 126. This is like, in fact, you can think of CGA showing a black hole collapse or, universe disappearing. It has to be a CGA. You cannot do it, right? Production budget wouldn't allow that. Not production budget. Basic physics wouldn't allow it. Same thing. So if this is like too complicated, there has to be something inflated over there, right? There has to be a bubble. Fine. The difference between the sum of the first two n natural numbers and sum of the first n odd natural numbers, all the stories with respect to Gauss and all that. Gauss in second standard, what happened to him while he was learning ABCD? All those stories I think you have seen in class. I'm going to do this real fast. I have two summations. The difference between the two summations. Summation 1 happens to be the number of terms in that sum into average value in that summation. Number of terms is given to be 2n. The average value, it's a linear thing, linear series. So if you take the first term, last term, divide by 2, you should get the average value. That happens to be last value is 2n, first value is 1 by 2. N into n plus 1 by 2 formula, Gauss formula, we kind of got it, right? This is number of terms into average because it's a linear sum. So this is S2, his number of terms is given to be N. This is N2 into average value in that, in that series or in that sequence. This is number of terms is N odd numbers. Average of the first and last odd number. This is 2n minus 1 is the last odd number. 1 is the first odd number. The average of them is 2. You can do this subtraction. Calculations you could do. This is this. I suppose cancels this one and this one cancels. This 2 will cancel with this 2. Yeah, this 2 will cancel with this 2. Answer is 1 is 2n square n. S2 is minus subtract, right? Differences. So this is n square. So I suppose this is n square plus n. So what you made use of is for a linear thing when things are increasing linearly. If you plot it in a graph, not a log, only suddenly they will start. We'll plot it in semi-log. It won't be a straight line, right? Plot it in a normal graph. Things, if it's a straight line, points lie along a straight line. Average value equals val1, first value plus last value 2. Of course, there are some problems where calculating this can be tricky, right? In this case, 2n natural numbers, n odd natural numbers, that can also be done. Just for a recall, that I suppose is r minus l plus rightmost minus leftmost plus 1 by 2 with footwork. It has to be either even to odd or odd to even. This has to be either to O or O to E. We'll stop there. Question: which of the following options represents the given graph? We live in the world of Deathmos, right? So this is, hey, can we describe this graph? We say, what are the properties of this graph? Like, put this graph into words. Look like a bow and arrow. That's a sort of a textual description. Can we describe it like points of interest? What is going on at 0? What is going on at infinity? What is going on at plus or minus infinity? Where are the maximas? And symmetries with respect to x-axis, even odd symmetry and all that. This is symmetric. This is even. When this is even, that kind of will rule out many options. Then this is all, in fact, even before even. So which of the things, this is positive, this is positive, can be negative, ruled out. This can be negative, ruled out. Rule out two options. Cannot be because it can take a negative value. F of x is in nowhere negative, right? Second thing is what I am quickly looking for. I'm also making use of my eagle sense. The function is even. It's a product of two things. This is even. X square is symmetric. It's 2 power minus mod x. That is even. Even and even can be even. This is even mod x, but this is not even, right? Even into odd or not, it's not even. This is even, this has to be even for it to be. So that makes this option. Typically, what should you look for? This is cases where notice even odd. Let's down some of the things that I would look for. One, check what I just did, positive or negative. Then even odd. Is it even, odd, neither, even or odd? Or is there any other symmetry, repetition, periodic, even or odd? What I showed here, what it boils down to, is there any sort of symmetry or repetition? Redundancy, symmetry or repetition. Is there any sort of symmetry or repetition? Repeating patterns, or is just redundancy. This is something that I look for. Then quickly I'll check for special cases at what is happening at 0, what is happening at infinity, what is happening at minus infinity. Can we quickly rule out any of the options? That is something that I do. Then, where are the maximas, minimas? Discontinuities, sharp changes in slopes, sudden jumps in value, discontinuities, continuities, right? Do they match with the function given? This is something that I look for. Discontinuities, extrema. You can easily spot them, visually spot them. If I'm doing visually, you can rule out many options. Extrema. What else? Notice is repetition, periodicity, all that will kind of show up here. Periodicity, all of that. What else? That's it, done. You are typically the first one or two things. Oh, another thing that I would typically look for is it monotonic? Monotonic. Or is it convex, concave? Again, these are very informative things. But typically, one or two things can easily help you rule out options. Is what I typically look for. And the examples, first even, I kind of quickly nailed down the answer. If you are saying B, is it for this question, right? It's for this question, right? This question, I suppose, is where is this? Where did this question go? Yeah, this question is better be A. Time now. Two identical cube-shaped die, each with faces numbered 1 to 6 are rolled simultaneously. Probability that one even number is rolled out on each dice. There are many types of, typical types of probability questions, 6 to 8 types. So an aptitude is fairly simple. So let me not elaborate all that. Let me solve. I have 3 examples from probability questions. Simple probability question. There is a 2D problem, area-based question, Monte Carlo question. Then there is a sequential, you do this, you do this, you do this. What's a probability type of question? Base theorem typically shows up in engineering mathematics. In his countable things, permutation, combination, either you can enumerate them, or list all the possibilities, find the answer. Or typically, you can use permutation, combination, and I can answer. That also shows up in aptitude. If it is property based, if it is axiomatic, property based, or if it is distribution based, typically this shows up in engineering mathematics. So these are the typical types. Let's quickly solve this. It's fairly easy. The first die, an even number showing up 1 by 2. The second die, and in the second die there has to be an even number. So this is 1 over 4. You could just write this down. In this case, fairly easy. In the figure shown above, PQRS is, it is a square. Shaded portion is formed at the intersection of the sectors of a circle with a radius r equal to the side of the square. Centers of x and q. Probability that any point picked randomly within the square falls in the shaded area. So what is the area of this? Ratio of the shaded area with respect to the square area. We have to find the shaded area. We have to, the moment you draw a line A, the sector area. The triangle area. You can find half the shaded area. in a double shaded green area. Yes, so this is essentially triangles, sorry, sector minus triangle. This is sector minus triangle. And once you know the green area, you can find twice the green area and all that. Let's quickly do this. This is 1/4 of pi r square. 1/4 of pi r square. R square. This is half into base into height. Half r square. This is a green area. Probability is required probability. This is into green by the square area. By the square area. We got, let's simplify this. Into, let's pull that r square outside of this by 4 minus 1 by 2 r square. These terms will cancel. This also get cancels, I suppose. There will be a 2 here. This cancels by 2 minus 1. Yeah. 5 by 2 minus 1. So typically there is an, your two variables. In this case, they have given a geometric figure explicitly. This is referred to as Monte Carlo. It's a, there are quick ways to find estimate of what pi is area of a triangle. This one is Monte Carlo methods, right? Very, very basic, simplest Monte Carlo 101. And typically there are two variables involved in probability. Again, you're going to do some kind of area based thing. So I call this, either you can refer to as Monte Carlo, or you could refer to this as area problems, area probability problem, probability problem. And this is specifically important when there are two random variables. It shows up here. They just ask you to find the areas, but if there are two random variables, quickly this area probability problem shows up. Classic example is this: two friends decide to meet. What is the probability that they meet? They'll wait maximum like 15 minutes from the time they arrive, something like that, right? Yeah. Now we have a sequential probability problem. Box contains 5. So sequence, always, just visualize that whatever I am writing, typically this is what is going to go on your rough sheet. Of course, not this. You are not going to write all this theory during examination. What I'm meant as, whatever I write near the problem, this much amount of rough work is what you are going to do. And if this rough work is exceeding one page, run away. Skip that question. 5 balls, same size and shape. 3 of them are green and green colored balls. 2 of them are orange colored balls. E.g. 2 orange. Balls are drawn from one at a time. Green ball is drawn, something happens. It's not replaced. Orange ball is drawn. Yes. So in this case, if you got a green ball, what happens? What will be left is, it's not replaced. So there will be 2 green, 2 orange. If an orange ball is picked, what it is being replaced. So what we'll have here in this case is 3 green, 2 orange. It is being replaced. This ball is drawn. What is the probability of getting an orange ball at the next draw? So the draw of interest is this. Draw of interest is this. Here we can pick a green ball, orange ball. Here we can get a green ball, orange ball. And the draws of interest, or we are not, the greens we are not interested in. We are interested in the orange ball. This we are interested. This we are interested. So here we pick a orange. Here we pick a orange. What happens here doesn't matter. What happens here doesn't matter. What happens here? What is the probability of this? This is a 3 out of 5 balls. 3 by 5 into 2 out of 2 balls. 2 by 4. Or this. So or is going to transform as plus. There is an into, they don't, let's not confuse it. That case is immaterial, which is what I meant. Or is going to transform into plus, and in this case, this is going to be 2 of 5 into again 2 out of 5. You can pull out the 2 out of 5 common and then do LCM GCD. Let me do that. So what we have here is 2 out of 5 into 3 by 4 plus 3 by 4, 2 by 5. This is 2 by 5 into 15 plus 8, 33 by 20. So that is 23 by 50. To show this with a slightly different color, so I write this. I cancel this two of this. If you're wondering what this is 444. Shall we move on? So aptitude questions are fairly easy. Typically, probability questions. Probability. This is enumerate. List on the cases. Enumerate or list. Enumerate or list. I'm not going to write that. Then you have permutation, combination, counting. Then you have sequential thing. you do this sequential thing. And then you have area-based things, Monte Carlo area-based things, area-based. This is what shows up in aptitude, probability in aptitude. These clearly show up in aptitude. Math, what shows up would be base, properties, axioms of probabilities and all that, and distribution, normal distribution, things like that. A base probability distribution. Properties kinda, almost everything. Rest of them are all, this is what typically shows up in math, engineering math. A few other things, but mostly this is a simplified classification. We don't have a lot of problems. We can kind of finish this faster. Function y of x is defined in the interval 0 to 1 on the y-x axis as this. No, so what we are doing is, notice we are doing some miscellaneous math-based questions. It kind of started out somewhere over here. Expected to know, analytical kind of ended here. Miscellaneous math kind of started here, right? I wouldn't call this math, but simple, math, miscellaneous math. Clubbed, so graphing, miscellaneous math. Then I clubbed probability with that. Now, there is few more miscellaneous math type of questions that are there. Let's quickly do this. Y of x is a function defined in which one of the following is area under the curve of the interval in 0 to 1. Area under the curve, you know how to calculate rectangles. Just give me 1 second. This is x-axis, this is y-axis. It's between 0 to 1. The milestones of interest are 1 by 3. Then you have 3 by 4. And then you have 1. The function value is 2 here, and it becomes 3 here, and it becomes 1 here. 1. This is a function value. We have to find this, right? So, and the 3 rectangle areas, you get the function value. Fairly easy. That would be, let's also mark this. You are at 2, you are at 1, you are at 3. Can someone quickly tell me what the answer is? Into 1 by 3 plus e into 3 by 4 minus 1 by 3. Starting point of calculus, right? Newton-Leibniz. Then we'll learn something called Lebesgue integral later on when you go to graduate studies. So this is 1 into minus 3 by 4, which happens to be, in this case, thank you, I got the answer, 13 by 6. More simple math-based question. Equilateral triangle PQR side PQ is divided into 4 equal parts. Side QR is divided into 6 equal parts. Side PR is divided into 8 equal parts. Of each subdivided part in centimeter is an integer. The area of the triangle QR is possible. So this is the question that, this is typical gate framing. First time you read it, second time you read it, doesn't make sense. There are some clues. Gate obfuscation, gate framing. There is a surprise factor, right? This is a very good example. You also kind of put up a separate video on this particular question. The idea is they take something very, very simple math question, 8 standard, 7 standard math question. They put it in gate exam. And to give that question some respect, they kind of frame it in this way. So some of the things that catch my eye are 4, 6, and 8. 4, 6, 8. Things are integers in centimeters, and then minimum area, right? When you divide, this is an equilateral triangle. I also need to write that. Okay, this is equilateral. All sides are equilateral. If you have that kind of a Hawkeye, eagle sense, spider sense, won't you write down this? You should guess they are asking you for LCM. What is the LCM of 4, 6, 8? What is the LCM of, what is the area of a triangle whose side is LCM of 4, 6, 8? That is what they are asking. At the stage, if you have eagles, right, the moment you write down this, you could kind of sense it. This is what I said, 7 standard, 8 standard question. LCM, 5th standard, 6th standard, right? Something like that. Yeah. The minimum and the least. And when you divide, it's integer on division. Sort of a multiple, right? Multiple or a factor. In GCF, LCM, there aren't many things, right? At this stage, you should recognize it. This step is particularly hard. So specifically, is that one case where if this LCM doesn't, strike you, you're not going to solve this problem. Why every other, even if there is a sound standard kid writing the exam, he would have solved it. But you couldn't recognize this as LCM because of that one reason. You couldn't like get marks here, right? This is highly unfair. So how should you deal with that situation? So right, this is like, what I did is, if you are having Scrabble, if you have played Scrabble, right? You're trying to form words, something like that. Right? You try to put all these letters nearby and try to quickly use this eagle eye, spider sense. I suppose the word for that is intuition. So you just cooked up some other thing. So and look for the essence, right? Interesting word. That is what I also try to do here, not with letters, but with information given here. Comes with practice, but I haven't found out. First pass, second pass, last 5 minutes. I have answered all MSQs, all NATs. I have get the zeros on ones, left and right, elimination, verification, everything. I have double checked all my answers, double check, cross check, triple check. All of that is done. Units, conversion, everything. Is it the right option? Are they asking for the wrong option? All of that I have double checked. Last 5 minutes left with this one question. Somehow I have spent only 7 minutes so far. There is 1 minute, additional minute that I can afford to skip. There is still space left in my rough sheet for this question. What do I do? Actually, a very reasonable situation. It's not very hypothetical. At that stage, I would ask, is it really, really easy? Because really, you're trying to look for very complicated, difficult things. All these easy things will go under the radar. Is it really easy? The reason you might not have noticed, recognized they're asking for an LCM is because you are trying to look for something more complicated. So ask this question. There is a good chance that you hit upon it. In this case, what they are asking for is the area of a triangle with an whose LCM is 4, 6, and 8. LCM of 4, 6, and 8. Sorry, LCM of 4, 6, and 8. How much is that? That should be 24, I suppose. So the answer is 1 by half into base is 24, and height would be root 3 by 2 sine 60 into the side, right? 24. I suppose this boils down to 6 into 24. I guess the answer is 144. 6 into 24 is not this, not this, not this. The root 3 I got from sine 60. So if you're stuck, ask this question. So sometimes in photography, they say, the best picture is behind you. You are looking at behind the camera, right? You are looking at something, waiting for something to happen. But the most interesting thing is happening behind you. You don't notice it. Then you go back with really bad pictures, right? So just ask this. Is it a really easy question that I'm kind of like missing out? Sometimes it does work. But the moment you cross 8 minutes, easy question, hard question, yeah, whatever it is, skip. Next possible easy question or hard question, next question will move. So I have put up a video on this gate framing surface. I kind of quickly said whatever is said in that video, so you don't have to go there. So I'm feeling slightly good. I'm not asking you to, this is called something. Referring to your own videos in YouTube, this goes by some name. I thought I was falling prey for that. No, I kind of explained that here. So let's go to the next question. Yeah, many easy questions from here on. Symmetry, spatial aptitude, is it? Mirror image of the above text about the x-axis. About the x-axis, you want to mirror it. Let's do the mirror, man. H will be H. X, A, X, I, it's a mirror. Fine, I kind of did that. Let's say, yeah, you can write this big if you want. So let's say, pretend this is your scratch sheet. Often you may have to write the actual thing so that you can draw the mirror image. My rough sheet will look like this. You will not be able to write this in the screen, right? So this is your mirror image about the x-axis. Water image, right? A, X, I, yes. So rule out the P, not this P, not this I, A, L, Y, yes, yes. So this is different. This is correct. Option is B. So write this down. Just rough scratch. You cannot write in the computer screen, right? So get it there and then fairly easy. Even you don't have to necessarily write this. You can stare at it and some of you can answer. If your visual perception intelligence aptitude is good, but I'm talking about average person. Syndrome is a word that reads the same forwards and backwards. In a game of words, player has following two plates painted with letters AD. from the additional plates given in the option, which one of the combinations of additional plates would allow the player to construct a 5-letter palindrome? Player should use all the 5 plates exactly once. Plates can be rotated in their plane. D. So it's ADJ, DDJ, DDDD, triple DJ, triple DJ. We are running short of vowel nouns cannot form a sensible 5-letter palindrome. Do they say sensible palindrome? Palindrome is a word. Is it a meaningful word or is it like a word? We'll come to that. R-A-R-A-D. Hey, there are two vowels. There is a possibility here. Z-D-D-A-D. It's no, but this dar, yeah, the dar sound is a gave us, right? It kind of, again, you look at this, how that answer is formed in the brain, right? What kind of, how does the brain recognize the answer, right? The computational mission, it's always filling patterns, but how it fills a pattern for a question like this, how does the recall of memory happens, and how does what impedes that recall? Suddenly you're stressed out, you're not able to recall something. What is the physiology behind memory recall, so that when it unnecessarily gets impeded and what to do about it? These are interesting things, right, for biomedical engineering from neuroscience perspective. So radar, the ter sound kind of gave me the possibility here. This is a dead end, and this is Italia. No, again, I suppose radar der sound kind of gave it away. B. How that happens? I don't know. This is like the more data. One is, of course, there is this inbuilt code. Partly it's algorithmic. Partly the more data you feed and the more practice you do, certainly the machine gets better. That aspect of the machine gets better. Tennis players are very good. Their reaction times are very good with respect to playing tennis. Their reaction times are not very good with respect to driving a car. So the reaction times, functions are specific to, improvements are specific to practiced functions. So the more kinds of problems you practice, the more efficient corresponding brain circuitry, the more efficient and the better the computational prediction mission is. This integrated evolution, integrated, there is this theorem for, not theorem, there is a hypothesis for consciousness. Integrated information theory. I don't know, fortunately Shannon is not alive. Let's go to the next question. How many rectangles are present in the given figure? All of a sudden, our students are finding, sir, there are squares. Where is the rectangle? Right? So this is a kind of bias that can get really, really dangerous. There are only rectangles. Sorry, there are only squares. Where are the rectangles? But fortunately, in this problem, the bias is not, there is this subconscious bias, right? It's not that strong. So most of you could easily spot the rectangles. Be systematic. There are small rectangles, there are longer rectangles, and then there are bigger rectangles. So small rectangles, there are 4 of them. Longer rectangles, there are 4 of them. So I'm trying to be systematic. Then this bigger rectangles, this thing, right? That is 2 of them. The rectangles, there are the other things are all triangles. So there is 4 here, there is 4 here. You can rotate this, I suppose. And there is 2 here. So the total, I suppose, is 10. But there are places where that kind of bias can be very strong. Rectangle or square? Rectangle or square? In fact, an example is this. If you have not seen this question before, in fact, many students, is it GATE 2022 questions, right? The All India rank 1 student, after the exam came up, sir, the aptitude was not touchable. Aptitude, it's very hard to actually solve questions from the aptitude. And this was one question in that aptitude, right? There are many questions, 2022 questions. Let's see. There is this 2023, 20 radar, then T20, 2022 area of rectangles, right? But he said aptitude was actually very hard. Who? This All India rank 1 student. And later on he said, sir, there was like some questions on this plot of family, property war. What is this? Plot of land must be divided between 4 families. They want their individual plots to be similar in shape, not necessarily equal in area. Land has equally spaced poles, marked dots in the below figure. Rope R1 and R2 already present and cannot be moved. What is the least number of additional straight ropes needed to create the desired plans? Single rope can pass through the three poles that are aligned in a straight line. No one is allowed to kill any other person in the family or any other families, right? One family is not allowed to kill other families. So that is, information reading between the lines. Single rope can pass through three poles that are aligned in a straight line. The reason students felt this to be hard because of an inherent cognitive bias. We have a bias to separate shapes based on equal area, right? Inheritance, if you have inherited a property, right? I want this cake. You forget inheritance. Birthday cakes, you want this equal pieces, right? Shape and all doesn't matter. I want equal pieces, perhaps the piece with more amount of cream, irrespective of the fact that the cream is really unhealthy. So that is the typical mindset, right? That is a very strong bias, not necessarily equal in area. So to put your natural animalistic instinctive cognitive bias aside, what you should give importance to is shape similarity. So I know students were trying to split this equally. Of course, they read it has to be similar in shape. Somehow, where do I split this? Where do I split this? It has to be, there is this equipartition of cake mindset somewhat coming here. Most students did not answer this question. There is a strong bias, strong cognitive bias that needs to be avoided. Actually, I would say this is one of the best questions. It was actually deliberate. There is a bias here. Deliberately, they asked this question. This is actually a very good question. There is a strong cognitive bias for equal splits of from cakes to plants to whatever it is. Strong cognitive bias. This is very strong. There is an urge to split things equally. And to go against that urge. Split. So I know students come out of examination halls and there are one or two students who found out the answer. And they are wondering, how come this is a stupid problem? Why did no one find the answer? Because there is a strong cognitive bias against you finding the answer towards equal splits. There is a strong cognitive bias to split equally, to work against that. What you have to go? We have to go against that. And permutation combination wise, there are many ways you can split this, right? So this shape, this is what is a giveaway. This has to be recurring. However you split, that the diagonal should show up. Rest of them, these are straight lines. There are straight lines here. The diagonal should show up. So at this stage, I am only looking for diagonals. Okay. The only diagonal here is this. That's it. There you got it. That's your first shape. Till now, your problem is you didn't know which shape. The shape itself is this. That diagonal was the giveaway. And the answer in this case is I needed 3 ropes. The real question is which shape is it? Look for cues on that. So which shape is it? Basically, we are at the last question of our aptitude discussion. 100 centimeter, this is spatial aptitude kind of questions. All of this is trying to visualize things, rotate, manipulate things, objects in your mind. All this augmented reality, right? Instead of doing it in a computer screen, desktop, or in a plane of paper, you have to do that in your mind, which itself might be an augmented reality. Right now, there's a hot topic in neuroscience. So 300 centimeter into 32 centimeter rectangular sheet is folded. Fairly easy. Let's draw it to reasonable scale. This is 100. Which direction? No, 100 remains 100. I'm sorry, this is not to reasonable scale. 100 remains 100. This is 100. This is 32. I have 32 over here. This is 100 over here. Give it some light brightness. 100. You fold it 5 times. Let me mark the folds. First fold, second fold, third fold. First fold, second fold, third fold, fourth fold. One more fold, is it? I have to use colors. First fold, second fold, hitting limits of resolution here. Third fold, fourth fold, fifth fold. So the beginning I have this. This is 32. The first fold occurs at 16. The second fold occurs at 8. The third fold occurs at 4. The fourth fold occurs at 2. The first fold occurs at 1. So every 1 centimeter you have a fold. So the shapes need to be similar as in pairs, since not all 4 are same. The question on the previous one, I'll go back to that. Let's finish this and go back. So 1, 2, 4, 8, 16, 32. So every 1 centimeter there is a fold. At this stage, I kind of recognize that. Every 1 centimeter. So you're folding it, you're going to get folds, all this, you're going to get folds, right? So every 1 centimeter, there is a stuff. So they haven't given folded 10 times. Because now someone will come and say, hey, folding 10 times is not possible. No. I did that experiment with an, instant mission. I applied, made use of Bernoulli et al., right? Pascal et al. And then I did that experiment. So now let's keep that aside. So if you fold it 5 times, the last fold is occurring at 1 centimeter. So every 1 centimeter, there needs to be a fold, and that should be a total of 1 till 31 folds. Total number of pieces should be 31. It is not 63. They are not going at a finer resolution. They are not hitting resolution. There is actually, computer resolution here, screen resolution, writing resolution, folding resolution. They are not hitting that, nowhere close to that. 5 folds, of course, 5 creases, even babies could roll out this option. It's between 32 and 31. It is R minus L plus 1, or is it R minus L, right? Counting problem. You could actually do it, fold it. You can fold the rough sheet 5 times and actually count for this example. You can say count it. It's not 32. It's actually 31. And this is 31. So we have answered this. I'll go back and answer that thing. Now we have an English issue, it seems. Plot of land must be divided between 4 families. They want the individual ponds to be similar in shape, necessarily equal in area. Now, is it like pairs similar in shape? No. When it says similar in shape, the plants needs to be similar in shape. 3 at a time, 2 at a time. No such distinction is made. That ambiguity, it's best to assume they are, all 4 are similar in shape. The most likely, most probable goes back to, someone called Jensen. There's a prior here as just all 4 are same. Don't complicate it further. So this is fair. 2 at a time, 3 at a time, and all that. That complication doesn't arise. So this is, even the English and all that is fairly simple. The simplest thing to do that is this. So anything else would be an unnecessary over complication. 2 rows are one, going against this Occam's razor, or some basic principles and probabilities. So R1, 2 or already present cannot be solved. What is the least number of additional straight ropes? Yeah, that complication shouldn't arise. That would be what I would refer to as an unnecessary complication. Or in more approachable terms, things should be made simple, but not simpler, right? Things should be made complex, but not complicated, right? This will be like unnecessarily, things should be as complex as they should be, but not unnecessarily complicated. So that would be an unnecessary complication in that case. This is the simplest best possible case. So that brings us to the end of aptitude, part 2 of aptitude discussion. So all the important information, I'll put it towards the end. This is fairly easy. Again, I'll hold on to this one thing. This is general aptitude is actually general sense aptitude, common sense aptitude. You can answer most of the questions using that common sense. And yeah, best thing to do is take one particular year, take all 10 questions from aptitude, solve that. Change the paper, mechanical, civil, electrical, computer science, just for practice. Once you check the answers where you went wrong and all that, redo it again with a different set of similar aptitude questions, which is typically from the same year, things are similar. Then choose a random year, test it and all that. To make your life easy, I have already made a list of handpicked questions and discussions. Yeah, many of this, there are lots of complications on what the correct answer is, what the correct question is and all that. Many of those are avoided in the things that I have given. So make sure if you append something here, push by KGF, right? At the end of the address, that link should work and the password should also be given. Any other questions here? Doubt in mock aptitude question that was not in recorded. Which aptitude is this? Which thing is not recorded? This is discussed in the class lectures. This is a fair doubt, and that is quite elaborately discussed in aptitude recorded video. Perhaps one of your friends could quickly share you which video that is. This is quite elaborately discussed. Many of the complications that I mentioned, Occam's razor, this, that, and all that, right? Actually will show up there. Things should be made simple, but not simpler and all that. In fact, some of the solutions floating around are also incorrect. So for that reason, it's a good idea to look at the class discussion. you're unable to locate the video, let me know. I'll help you with that. Fine. If there aren't any other questions, let's. Some of you are having difficulty accessing mock tests, right? Quickly do you do that? At least those who are in class, or in fact those who take the mock test for any reason, I have to locate their test. Having a unique identifiable name kind of helps me locate it. There is a unique name. Is the volume fine right now? Be fine right now, I suppose. I'm just using. So, I need unique identifiable name so that I can locate your test if there is a need. For that, what I have done is, for all Zoho, all the tests are done in the Zoho surveys, right? So it has this https://survey dot zohopublic.com/zs. And then there is a string of characters for each test. Let's say for the analytical aptitude, this I suppose is FNZ6NF mark, and I have a name here. Cool. If you click this link, if you copy paste this, put it in the address bar, it will say survey link is invalid. What you are supposed to do is append a unique name here. Let's say Pushpa 2. So if Pushpa is coming back to me trying to locate his test, I can actually get back to the test. If you append it and then click enter, this should ask you for a password. And of course, wherever you got this link from, that should also have this password. Typically, Dhoni something, right? Yeah, this is quiz code or password. Should also be found wherever you found this link. Code or password column. Typically, this is a Dhoni something. Now, a quick way to practice for aptitude is take, let's say, 2020 DM paper, all 10 questions. This is specifically for aptitude practice. Then take the same 2020. Typically, for one of the other branches, these are related. Quickly, review your test and again do 10 questions here. Needed, again, take one more paper from the same year and do it. And a week or something like that, do it from a different year, 2023. You can go back in time. You don't have to stick to biomedical 20, let's say 1995, something like that, right? You could always do this. And set of questions that I have, these are handpicked illustrative questions. Since I have both the topic wise, that is analytical, numerical, and all that, topic wise, there are also, full 10 question sets, right? That covering everything in general aptitude, complete full general aptitude, right? I also have this. So video discussion, answer key, all of that is also available, right? Full complete GA. You could make use of this if you want. And these are specifically handpicked, very illustrative examples of respective topics. And to test, again, I have about 3 complete sets, right? That are available. You could make use of it. This is one thing that I wanted to say. So just append unique name and you should be good here. If you want to give the test again, you could append Pushpa 1, Pushpa 2, Pushpa 3, Pushpa 2 race, Pushpa 2 rule, right? Pushpa 3 rampage, all that you could do. Now let's get back to our PYQ discussion.